So this is the Attractor Point, and I guess Dynamo exercise we'll be looking at today. We'll be looking at recreating this shape. So obviously, Matt, you know this, but I'll just kind of go on this. So under Manage, we go to Dynamo up here. Once you have a Revit file already open. While this is open, I find it's helpful to always kind of like tell people how things open, because I think a lot of tutorials online don't typically do that. You know,
yeah, they skip the first step.
Yeah. So it's yes, Dynamo. We want to go to New. So this is the Dynamo interface. There's a lot of stuff going on in Dynamo. So we have our different functions over here, and we also have add-ons. We won't really talk about add-ons. I'm sure, Matt, you have probably a lot of add-ons on yours. And that's kind of the basics of this part over here. There's more information up here, but we won't really get into any of that right now. I think this is kind of primarily your place that you want to live. And then over here, there's two different views for Dynamo. We have the 3D view and we have the 2D view. And so in the 2D view, we're going to be looking at creating a element. So I'm going to go up here into the library, and I'm just going to type in point. And we're going to go point by coordinates. And I'm just going to click and bring it over here. And so if we go point by coordinates, there's a few different things we can do. Let's bring in a slider. So let's go to, I forget the name of the slider we want to bring in. So let me just see here. Yeah, we want to do just a number slider. I'm going to use this number slider. I actually kind of prefer an integer slider, just because I don't really want the step to be like point. I just want whole numbers. And I'm going to change the max to 20 just because I don't want it to be too crazy. And so the way Dynamo works, and I find the best way to teach a lot of software is to not necessarily talk too much about the interface, is just to kind of really just jump in. Because I think the interface kind of bogs down a little bit of what's going on. So I'm just going to bring this X into here. And so we have our point right here. So you can see our point. If I move it over here, we're at 0, 0. And by default, Y is 0, and the Z is 0 as well. So if we move this, you can see our point move along that line down right here. So, really, understanding a point is really the basics of understanding a modeling and parametric modeling within Dynamo. And so the next thing we can do is we can kind of make this a little more complicated. So let's add another number slider. And we're going to set up similar parameters. So I'm just going to cleanly move this up here. Step is 1, and we're going to change your max to 20. I'm just changing the max to 20 right now, just so we're not dealing with such a big number. Not that this is that important, but the units of Dynamo are essentially units. And when those units translate back to Revit, they'll be using the same units that you're working in. So if you're working in feet and inches, it'll be feet and inches. If you're using meters, it'll be meters. If you're using millimeters, it'll be millimeters. So it corresponds to a similar unit convention of whatever the 1 is equal to. So again, we can add a slider to the Y, and you can see that that's moving. And then now we can do this, and we can move it, so we have our 8, 8, or, whatever it is. And then, so the last kind of variable within this is the Z axis. So let's add another number slider. So I will right click and I'll type in the command I want quite often. But over here, we can use input basic number slider. And then we also have geometry, points, point by coordinates X, Y, Z. So that's, there's kind of two different methodologies. I typically use the right click a lot because I find I can get to whatever element I need to get a lot faster.
So why wouldn't we use X, Y? Because
yeah, so the Z is important because the Z is our height.
Okay.
So right now we're going to be functioning in Z equals 0, but one thing I found with teaching Dynamo is it's actually really helpful to have the Z there, because you want to know, like, I think Dynamo becomes very complex because it's not just modeling, it's also math, and it's a lot of math, right? And so I think showing that the Z is 0, I think from a comprehension perspective, it's a lot easier to understand that, okay, we know that this is not going above, this is on, we're only working on like the X and Y plane. So, you know, essentially right now with the Z being 0, we're working in 2 dimensions. We're not working in 3 dimensions, kind of. So that's kind of the first place to start. And that's how you you get a point and move a point. So the next piece of complexity we want to add is we're going to disconnect these X, Y, and Z from the points. And we're going to move this points by coordinates over here. And we're going to add another command called sequence. If I can spell. So in sequence, I'm just going to make all these, make this one a 1 for now. So in sequence, we're going to use these same number sliders. It doesn't, the fact that we change these parameters, I guess, is not incredibly important right now, but I like to keep step as 1 just because I think that's kind of a nice number. And I think having a max of 20 just doesn't make it too difficult and too outlandish to comprehend. So the reason why I showed you the XY thing first is, one, you know, we actually have a tangible element that we're producing. So now with sequence, sequence is essentially, we're going to develop more than one point, and we're going to do so in a more automated fashion. So the start point is where we're starting. So we might want to start at 0. We might want to start at 1. The amount. So let's just keep our amount at 1 for now. And so the amount is the amount that we're going to be arraying this, the amount of copies. And then the step is the increment, or so the spacing between the points. So let's say the step is 10. Let's make this 5, and we'll leave our start as 0 because we want to start our sequence right at 0. I think that's the best way to understand it. So I'm going to bring this sequence across into the X here. So now that we have that done, you can see we have 5 points, 1, 2, 3, 4, 5. And our size between them, which is a little bit arbitrary in this right now, but the size between them is 10 units. So I can increase the size and they get farther apart. I can increase the amount, which increases the amount of points or decreases the amount of points. So that's kind of the first kind of cool thing. So the next thing we can do here, so let's say we want to do a sequence in X and Y at the same time. So let's pull this sequence right into the Y here. And so now you can see what it's doing is it's stepping in this X and Y at the same time. So we're going, you know, 10 over, 10 up point, 20 over, 20 up point, 30 over, 30 up point. So it's basically, it's stepping in both the X and Y at the same time, which is why it's going on at an angle. So what I'm going to do here is I'm going to create a group. I strongly believe in trying to keep really organized when you're doing Dynamo, because especially when you're learning Dynamo, there's a lot going on. And so we're going to call this creating an array. And just another couple organizational things. What I like to do here is I'd like to type start, and I'll put in brackets coordinates we start at. I don't know if I spelled coordinates wrong, probably. I feel like I spelled it wrong. No, I think I spelled it right. Well, look at me go. So this is the amount. So I'm just renaming these number sliders just to, maybe what I'll do is I'll say number slider, and I'll put amount of points. I'll be able to do this up here too. Just leave the original number slider.
So if you were to also connect that sequence to Z, would it then start stepping up as well?
Yeah.
Yeah.
Yeah, and so going back to the interface thing here for a second. So if we click Enable 3D, it allows us to actually move the location of this. Yeah. And then we go back to this, we see our kind of parametric thing here. So I'm just going to disconnect Z because we have a step in here. But I just wanted to, I like to do this naming convention thing first. And again, just from an organizational perspective, it's just nice to be really clear in what's going on. So let's say this is step. And the step is really distance between points. Capitalization consistent, not really consistent anywhere, but so I'm going to group this because we're going to make a change to this, and I want to illustrate that change. So this is creating the points. But what I'm going to do here is to create the array. So we need to right click, and we need to turn on lacing to cross product. So again, I like to be pretty, I don't know how I change, just change the font size down. So change lacing to cross product. And so what that does is it essentially creates a list. So again, lacing cross product. So it's like, okay, well, let's do 0x. So 0x, and then we'll do 1, 2, 3, 4, 5, y. And then we'll do 1x, and then 1, 2, 3, 4, 5, y. Yeah. That's kind of what the cross product how it works. It's creating an array of those elements. So
Dynamo is the same way. Grasshopper, you can you pop in one of those? I forget what it is in Grasshopper, but it's just a list that it reports, so you can see. Okay. So it automatically is there. You don't need to make it part of the actual string. Yeah. Okay.
Exactly. So this is the list. So you can see where all the points. So you can see the z-axis is 0. You can see we have 0, 0, 0, 10, 0, 20. So our step, going back to our distance between points is in increments of 10. So yeah. So that's actually a great point because it's really helpful. So now you can see. So here's our list, 0, 10, 20, 30, 40, 50. And so what this is doing when it does the cross product, it's taking and basically finding all the possibilities of that number, which, we have, 5 by 5 or 6 by 6. So 36 different points. So the toughest part with Dynamo, I think, is the math. And, I think, I guess part of my goal is to create a lot of notes and provide a lot of feedback, especially on different aspects of the script that I write, because I understand it is difficult and it's a lot to handle. So now we have that cross product. We can start to do stuff with it. So we're going to type here. We're going to type circle by point and radius. And so we're going to take this point and add it into here. So we're going to have a circle now around every one of those points. And so the next thing, there's a couple different things we can do. Like, so I can add another slider in here. And a number slider. And we can go down here, change, again, I'd like to change the step to 1. I'll just change the max to 20, so we're not dealing with huge numbers. We can bring this into the radius. And so you can see once I grow this, the radius of those circles work. So the next, I guess, bit of complexity we can add in here is a randomizer. Because, you know, all these circles are all the same right now, and, you know, what fun would that be, right? So let's take this slider, and I'm just going to turn off these lists right now to have a little bit of breathing room. So I'm going to take this number slider, and I'm going to bring it down here for a second. And so we're going to do list create. And we're going to do math random. We want this math random list. So we're going to bring this list into the amount, and then we're going to bring this amount into the radius. So the problem with this is the list here has to be the same number, I believe, as the X value. So we need to have 6 lists here, I believe. Am I wrong? Yeah, 6 lists. 1, 2, 3, 4, 5, 6. What do we got going on here?
Doesn't it read 0 as 1? Like it starts 0, 2, 3,
yeah,
4, 5.
Yeah, we need a minimum of that. I wonder. Oh, sorry. Yeah, this is what we need to do. We need to do this. Forgot about that part. So it doesn't actually matter if we have more items in the list, as long as we have the minimum. So here's kind of the one thing that's like a little bit awkward right now, because our step is 10. Like maybe we'll move our step down to like 6, and then the numbers will get a little bigger there. Yeah, so you can see we're now starting to kind of do something interesting. So we're taking a list of random numbers, and we're applying that random number list to the radius. And so essentially each point has its own radius. And you can see the list here that's created is a pretty wild list. So there's a couple things you can do with this list. Let's maybe take the minimum to 5. I don't know if that really changed. That won't really change a whole lot. So the one thing we could do is we could do some sort of multiplier. So we could go divide or some random list radius. So we could do multiply. We could say that we want, let's just color multiply. So we want, see all these numbers are all decimals. So we could just say we want to multiply this number by 5. So we could do number. And I could just type in 5 here. And basically what we're telling Dynamo is we want the minimum number to be 5. And now we're multiplying some sort of variable, or well, I guess we want the maximum number to be 5. That makes sense. Maximum number, yeah, it makes sense. Maximum number. So you could say we want the maximum number to be 3. So when we multiply any of these numbers by 3, they're all less than 0. So it's all going to be less than 5. So that's kind of a way to have a little bit of control over the radius, since all these numbers are decimals, and allows us to give a little more variability to that. So I don't know. I know you obviously, Matt, you know a little bit about Dynamo, but you can kind of start to see, if I'm not wrong, you can start to see like just a little bit of possibilities of this. You know, we have a grid. You know, we can change sizes. So next thing, we have all these circles. So let's make this into an actual object. So again, I'm going to group some of these items together just before we go too far. Clean all this up a little bit. So this is random. So we have that. We have our circle here. So let's go to surface by patch. So this essentially takes this curve, this circle, and fills it in. And then the next thing that you can obviously start to imagine is we could extrude this patch. We could actually just take these variables and we can look into Revit. So if I go over to here, you can see that everything that we're doing in Dynamo is actually being shown in Revit. The other thing I'll just kind of show you quickly, I'm just going to type VG for visibility graphics on the keyboard. Oh, sorry, I got to click Revit here. And you can see where this is starting, and it kind of looks like it's starting right in the middle, but like the point is starting right in the middle. So the one thing you'll note from Revit, and this has kind of been on newer releases, I think in 2019 they started showing this, or 2020, they started showing the internal origin. And so you can see that this first point actually starts at 0, 0, and that's where 0, 0 is. That's at that internal origin. So the only reason why I bring that up is that's super helpful to understand when you're using Dynamo to model or alter something, just so you understand where you're making that element. So that's where the internal origin is. I'm just going to turn it off right now, but that's where it is.
Is there a way, because in Grasshopper you can kind of select, like if you had a surface modeled already, you could select that as what, like the bounds of what it would be applied to.
Yeah, and so my short answer to that is, I think to what we were talking before, I think that's part of the missing function that we need to develop for this project. So like I can create these elements, and I'm just going to show you this one more thing before we talk about that. But we can do import instance by geometry and view. By geometry. Yeah, so there's one of these, two little things. And so now, so before you could see these objects, like you see these circles, but like even if I go to 3D, you can see them, but they're just kind of like blue lines. There's nothing really there. So if we bring Dynamo back here and we actually join that, and so what that's going to do is now we actually have a surface here in. Let's see if it'll show. So we have a surface now actually loaded into Revit. It's not just a circle. So that's kind of like how you get something in there. And so going back into your question, and this is something, I think maybe like step one for this assignment is you to kind of play around with creating these shapes and developing a pattern. And then step two, which we can work on next week or the week after, is taking that element and implementing it into a facade or a wall, and using that to create some sort of shading device. But over here we have a Revit tab, and so the Revit tab is really just all about the elements. So we could do, I think actually it might be a good one. I think we can do pick wall. No, I actually don't know what the actual function is. Wall by location. Select wall type from current. Gets the name of a specific wall type. Select wall element. Drag wall. Select element. Select multiple wall elements by element. So the one thing that is really interesting about Revit is every item in Revit has a unique ID. And the kind of crazy thing about Revit is if you and I were to both work on the same project and model exactly the same way, I think the unique ID is somewhat based on the computer processor or something like that, because our unique ID, all of our IDs for all of our elements, even if we like step by step we copy each other, it'd all be like each ID, each element would have its own unique ID. And so kind of a cool thing in some respects from Revit. And the only reason why I bring that up is we can actually use that unique ID to actually grab a specific element. So I don't know exactly what that would be. Maybe wall by name. So that's wall type by name. Wall location, wall by face. Gets the name of a specific wall type. That's the one we clicked before, isn't it? Select wall element. So this is probably what we want. So let's go here. Let's draw a wall. So I'm going to go here in Dynamo. We're going to click select. And I'm just going to move this over my other screen here. And I think when we click select, yeah, we click that wall. And so now, here we go. So now you can see the element number of that wall is selected. So we can use that as a way to do something with it, I guess. So that's I guess part of my challenge that I'm going to work on for you is trying to develop that logic and understanding, how to actually grab that element and how we can use it to cut or something. So that's essentially where we're going with this. So I'm just going to leave this select wall thing here just so we have it. I'll upload this Dynamo file after for you as well. But so that's kind of the cool thing. So you can grab everything from Revit. You can actually pick particular items in Revit. You can grab, and obviously you're very familiar with grabbing information from Revit into Dynamo, using it to process it in some way, maybe Excel, what have you. So this is kind of the first step. So instead of doing surface by patch, I'm going to delete surface by patch. And so we can do, might have to go into a different, I need to go into a different lesson plan here. So let me just give me 1 second. So, essentially the start of our script is really the same. We want to create an array. We want to create that array in a certain direction. But what we want to do here is we want to, instead of let's find the actual. So instead of creating a surface, we want to extrude that circle. So we can go to extrude. I think we want extrude curve. direction, distance. Yeah, we want distance. So we want to extrude that curve. Is that the right command? Let me just actually, I can do something different. Extrude, because the way, so extrude would just extrude the circle. So it'll only include the walls, but we want it to be a solid. So we actually want to extrude as a solid. And so let's click this circle. And you can see now we don't have, just a 2D form, we have a 3D form. And we could get a little bit wild. We can plug this random generator into the distance as well. So we can have different heights and different radius. But the one thing you'll note is the height and the radius are now going to be the same because we're actually pulling in, it'll be pulling from the same list, so it'll be the same number. So, one thing we could do is actually grab this group, and I'm just going to hold down the Alt. Is it Alt command? I think it's Alt. Yeah. Control command. Sorry, that's what it was. Control command.
So then you'll have one that does the diameter and one that does the height.
Correct.
Okay.
Yeah, so now these numbers are not going to be corresponding. We could actually say we want the distance to be 60, or something different. So that's kind of a nice little thing there because we can start actually having more control over what that is, right? So, and then again, same kind of concept. You can see how these are, somewhat of a shaded element, and we can actually bring import instance by geometry, and now these are actual, tangible Revit elements that we can select. I don't think exploding, I don't know, maybe a partial explode. Yeah, I don't.
It doesn't like that.
I don't think it likes when you do that. And so, I think our goal is gonna, like I said before, to use this kind of methodology to, not really just create a funky shape contest, right? As much as that's what, this assignment that we're doing is kind of, but it's funky shapes for the purpose of experimentation and, understanding. And, I think your goal should also be to create a funky shape and use the massing tool, because I almost guarantee you probably never use the massing aspect other than creating families. But other than that, you probably never use the actual massing aspect of Revit, right?
Outside of school, no. I mean, I would use it as a SketchUp. Like if I didn't want to do something in SketchUp, just do everything in Revit.
Yeah.
Yeah.
Yeah, that makes sense. Yeah, so that's so we're gonna create a funky shape, but what we're gonna do for you, like I said before, is we're gonna try to use Dynamo to somehow create a perforated facade of some aspect to, let light in or what have you, right? So so this is the basics, obviously, of this, right? So the one thing you'll note is our array up here, we're plugging it into the X and Y at the same time. So we want to have a little more control over that. And so what I'm going to do here is I'm going to call this X. And what we're going to do is we're going to just bring this up here, and I'm going to hold control and copy this whole group down. And we're going to go Y. I think maybe for the purpose of this, I'm going to try to actually condense this a little bit more. And do the same up here. So we have our X, our Y. Let's just bring our Y in. So now we can actually have more control. And so here's, this will start to get a little more interesting. So instead of stepping or having 6 points in the X or in the X and Y direction, now in the Y direction, we can actually change the number of elements we have going in that direction. So this gives us a little bit more control over what we're doing. And obviously you can see where this is going. We can take it one more step further, and we can have control in the the Z direction as well. This is going to get a little bit crazy. So now, you know, our objects are actually three-dimensional now. So we're actually arraying. I can never figure out how to navigate all these different programs. Every program like moves a different way. But now you can see we actually have a 3D object going, you know, not only up, but also, or not only X and Y, but also up. And so to go back to this for a second, you know, we could actually take, I think we need to take the X, we can't take it down below 1, because if we hit it at 0, there will be no points, right? So we want it to at least be 1. So you can kind of see where this is going a little bit now. So, you know, if you think about this as in form of a wall, you know, we want, if we have the wall in a certain position, now we want that wall to be, you know, it's either vertical or horizontal. It really, I guess, doesn't matter a whole lot, but we can have more control over that. The only downside to this random number generator is the problem with the random number generator is you have to edit this list, because this list is based on, I think if we were to go more than the X, so which is 6, this list would get voided. So if I take this list up to 7 or 8, you can see the points are there, but there's no objects. And so I guess the creation of a list in this way is a kind of a flawed methodology. And so we want to come up with a different way of doing that. And this is where it comes into Attractor Points. So maybe what I'll do is, let me save this as its own file. I'll do save as here. Let me see where I want to save this. So I'll upload these Dynamo files. I'm going to create a separate module. I think the fact that you really wanted to do this, I think, is really great for this course, because I'm going to create a separate module that's going to be like project 2 extras. And then I'll create a separate module called project 3 extras. And it's just kind of, it's not really like, it's not going to really change your grade at all. It's just, you know, going to be a way for you to challenge yourself, because I think there's, over the course of this, me teaching this, there's always people that know Revit well, and it's like, okay, well, you know, great, Corbin, I know all this stuff already, right?
Yeah.
So, so I'll save that. So let's, I'm just going to get rid of these. So I'm just going to save as, actually, and do one more save, and we'll call this Attractor. Is it Attractor or Tractor? I can't remember. I don't know. I'll figure it out later. One day I'll learn how to spell. Attractor Points. So we're going to delete this, this random number generator. And what we really want to do is we actually want to create a point. And the cool thing about this is, if you think about it from schematic design level, and the best example I have is the sun. And so you could think about this point. A point is going to be the sun. And what we're trying to do with this facade is we're trying to direct the sun in a different direction. And obviously this example is not that metaphorical, because that, you know, that's kind of what we want to do with some sort of shading system, right? So we want to first define an attractor point. So we want to go, essentially we want to create the point by coordinates, and we want to do a slider for X and for Y and for Z. So there's our point there. So it's kind of way over there. Let's move it up here. So I'm going to change this to 20 to maybe to 10. And I'm just going to try to get the point kind of, yes, the point's kind of right there. I'm just going to change this step quickly to there. Should change this to 20. So you can't tab in Dynamo. So this is going to be our attractor point. So this is a point that we're going to use to essentially alter, I guess, the form of these objects. And so I guess, you know, not to be preachy the whole time, but what are your thoughts? Like, how, if I were to kind of put you on the spot, like, how do you think we should alter these points, or how do you think we should figure that out? Any thoughts on that?
Distance from
the
attractor point.
That's exactly, and it's actually distance 2.
Okay.
Yeah. So we want to create distance 2. And so we have our geometry, which our geometry is actually going to be this point up here. And then our other point is going to be that point. And so we can pull out the list here. And so the list is going to start to give us some numbers. And so now what we can do is we can use that list to, you know, alter the radius. So that's obviously pretty obnoxious. Maybe we'll just alter, not necessarily the radius, but we'll just alter the diameter. Yeah, so you can see that that's a little awkward, but you can see that it starts to change in height based on the distance to it. So, you know, this point is kind of roughly in the middle. Maybe I'll move the point a little bit over. I'll change the where did our point go? Yeah, so our point is right there. It's a little red dot in the middle. Yeah, so there's our point. So I think that's pretty close. You can see how we move this point, it changes the height of those objects. So essentially that's the purpose of an attractor point. And part of the reason why I want to use this in the form of a shading or a perforated facade element is I think it's the most tangible way to understand the purpose of an attractor point. It's like, okay, we want to take the direction and the location of the sun's coming in and alter the facade based on that.
Yeah. So what would happen if you were to add the to the array in the Y direction, make it like, you know, 10 long, and then double the attractor points and have one, you know, kind of at like 7 and 7 and 7, and then one at like 3 and 3.
So to have more than one attractor point?
Yeah.
Yeah, essentially the same thing. So you would, what we would have to do is, you know, let me try to do this. This might be interesting. I was always good at math. I was never great at math, right? In high school and stuff. But I always found math fascinating, and probably really the reality of it is I probably just never spent enough time on it, right? But it is fascinating. Like this. I think part of the reason why people have such a hard time with Dynamo and Grasshopper is the math. It is so rich in math, right?
Yeah.
So let's say we have 3 attractor points. What were those numbers you gave me?
If you were to do like 7 and 7 and then like 3.
Yeah, actually, let me do this. I'm gonna turn this around so we can see the attractor points.
Yeah.
So we have that one there, and then we have this one. So maybe this one is like 14. Where did this point go? Yeah, so there's 1 point there, 1 point there, and 1 point there.
There.
So what we need to do now is we can't just plug all these distances in here because they'll keep, those kind of turn each other off.
Yeah.
So what we need to do is we need to write some sort of script to basically evaluate. That's a really great function applies. This is going to take a minute on the math side. So what we need to do is we need to find the lowest distance, and the lowest distance will essentially govern. So here's where my brain's probably going to shut down a little bit. So math functions. Let me just see. Oh no, logic is what we want. Logic and or operators maybe.
I thought it was, if I'm thinking where it would be in like Grasshopper, it would be under functions, I believe.
Yeah. Functions. So be min.
Is there a range? Or no, it would be.
I wonder if, let me just see if minimum can do more than lesser of 2 numbers. So I could do this. I could do, what's the difference between these two? Values and integers. Yeah, I'll just do values. So I could just do this. I could just do this twice. And so here's, this is a little bit complex, but instead of extrude curve as a solid, so no, actually we want to go circle by center point and radius, circle by center point and radius, and normal. So this is where we start to kind of, things start to get even more complex. So instead of bringing that in, we're going to bring that in there. And if you remember back to your physics days, the normal is essentially the direction.
Yeah, because I do a lot of 3D printing and laser cutter.
Yeah.
So to set it all up so that it doesn't go from here to there to there to there, you can set it on the laser cutter to follow the normal.
Yeah, exactly. So normal by coordinates vector. I don't know if this will work. Vector. No, I think, yeah, I think I'm thinking too complex. So Let's see. How did I do this before? That is a great question. Give me 1 second. Where is my... script I wrote before? Geometry distance 2. Normal. Okay, here we go. So rotate normal. So that is kind of what I did. So yeah, vector by coordinates. And then we just do sliders. So so I'm just going to do an integer slider actually, because I don't really want to. Actually, do I want to do an integer? No, I do need to do a number slider. We could actually just use a number too. Like this is getting a little bit complicated, but yeah. I'll clean this up in a second. It's a little bit messy. So I'm going to move this. Up here. Sorry, I just need a minute to organize here. So rotate normal. Yeah, I like to tell people too, especially with Dynamo, it's really good to get in the habit of leaving yourself a lot of notes.
Yeah.
Because it gets really complicated. So this, just pull that further. I don't know why that's like grayed out like that. It's a lot of lines. I'm not going to worry about cleaning those up too much. This is finding minimum distance between multiple attractor points. And then yeah. So here's the thing about normals is we want it to only be in one direction. So typically, well, I guess not typically. Using 2 zeros and 1 equals. I'm not doing a very good job explaining this, but or I'm doing a very good job writing this. But using 2 zeros and a 1, it kind of creates like incremental directional changes. So north, south, east, west kind of thing. So we can make this a 1 and this is 0. So here's a this is probably a better way to describe our attractor points is now we have I'm doing a very good job of navigating Dynamo tonight.
Yeah, now you have 2 points creating the
yeah. So now let's so we get 14. So what point is this? So that's that point. So that point's kind of in an awkward spot. Like it's not really doing a whole lot there. Let's drop it down. And let's increase its. And let's make this to 25. See if I can, yeah, there we go. And then let's make this one, change this one in the Z down to like. So is this, so I don't know if this point right here is doing anything. So we have the distance between there and there, distance between there and there. So it seems like this mass down here is not doing anything. Like if I did this, did that change? I think it did actually change.
Yeah.
No, it didn't, did it? No, it didn't change at all. No. So this, for some reason, this bottom one's not doing anything. And
do you only need one in?
well, we have 3 points, so somehow we need to find the minimum of all 3 points.
Can you add values to it? So if you were to like right click.
No.
Because I know in Grasshopper there are a couple of the functions where you can just add values.
So I'll have to think about that, figure out a way to, yeah, because right now it's not really, oh, maybe it is. Wonder if I selected as value 2, not value 1. I don't think that makes a difference at all. But anyways, that's, we could also, instead of affecting the distance, we could affect the radius. And radius is pretty large. The radius is a little too large distance. What we could do here is we could do divide. We could divide this by all right, so you get this can get really complicated, right? But I can just take divide by 2. Divide by 5. So the radiuses are changing based on the attractor point location, but they're not, I don't know, they're not crazy huge anymore. Maybe we'll go divide by 6. That's a little bit better. So, you know, and this is kind of interesting too, because if you think about this in some respects, and maybe this is not really the best, I guess, way to think about it, but you could think about it in terms of, okay, well, the closer an object is to the sun, it maybe has more depth of penetration of sunlight. And so therefore it maybe has a larger radius, or maybe it has a smaller radius if you're thinking about shading. So less light penetrates, and you know, you're still able to maintain that view through that hole, but it's not as big of a I guess a void is probably the best way to describe it.
Yeah.
So that's yeah, this is getting a little bit wild here. So yeah, that's yawn. So that's kind of the start to Attractor Point. So you know, we can change this to be 1 and this to be 0. And so it'll change that direction. And then what we could do over here is we could change our our points, this to 1 and maybe this to 8. And it'll start going in this other direction now.
Yeah.
You obviously have to change your point. So it's there's a lot going on here. A lot going on. But you can start to see the workings of how I guess Dynamo works. And I think we definitely went really fast through this, and we kind of jumped a couple steps. But I think that's kind of a good place to start for this. And and then we can bring these objects into here, and so you can see those objects in there now. These are the objects from the previous file we had in. I can just delete those. And so now I guess for more of our personal discussion, maybe next steps is, okay, so how do we take this wall that we've created and how do we do something with this wall? So imports instances in geometry. Well, maybe we want to find origin, or maybe let's just type origin. I don't know what I'm doing right now. Or origin by normal, origin by radius, origin by vector, origin by direction. Because what we want to essentially do is reset our 0, 0 to be the wall. I'm just trying to, that might not be the proper way to do it, but I'm just kind of thinking out loud here. So element, analyze, maybe face, view face points and value. I wonder what this does. That looks complicated. That's probably not what we want. So we have views, references, filter rule. Elements. Let's go to wall. Yeah. Now I'll think about that a little more, and I'll see if I can get you somewhere with that. But I think hopefully this will give you something a little bit fun to play with. And so I guess maybe my one ask of you is, what I'm going to say here is you can't use circles. So you need to find a different. So that's going to, I guess, be my one challenge to you is not to use a circle, is to figure out how to use another shape.
Okay.
And I don't think it'll be too much of a stretch, but we can certainly talk about that as you figure out. But that might add, I guess, one little layer of complexity to this. So
yeah. Can you use Dynamo stuff like this within families? So like if you were to make a new family for like a curtain panel, mm-hmm. and then apply this to curtain panel and then do 5 options of it.
Yeah.
And then take that to a larger facade as a whole. Right. So then you're playing around with like panel A, panel B, panel C, and
Yeah. And then you could do energy modeling on it. And yeah. No, I definitely you definitely can do something like that. Basically any. I know families you can definitely use Dynamo with. I don't know how far. I don't know if you can do it with like. I assume you could probably do it with adaptive components for curtain wall systems.
Yeah, it would need to be adaptive.
Yeah.
I think in order for it to work.
Yeah. I don't see any reason why you couldn't do any of that. There's definitely some pretty kind of cool implications as you start to kind of layer more information on this, right? Because you know, a lot of everything I have here is like literally the basics to, you know, starting to understand this. And, you know, it's okay, you know your one facade is facing, let's just use the obvious and I guess easiest way to describe it. You know, for our climate, our facade's facing south. Okay, well, we don't want to have direct south sun all the time. And then, you know, furthermore, we also want to protect in the wintertime, we don't want to have low level sun shining in our windows like all day long, like having to like glare and all that kind of stuff, right? And so, you know, when you're designing a curtain wall panel or something like that, and so this is where, you know, maybe diagrammatic, you know, kind of sketches come into play. It's like, okay, well, here's the sun angle max, here's the sun angle min. Well, we can bring light in at any angle that's not those angles. So, you know, maybe you have these cylinders that we have in Dynamo right now. Maybe they're angled down, and the cool thing about them being angled down is you could actually still have a view down, especially if you're in a taller building, right? You'd still have a view down. It's just you wouldn't see directly across. And so, I don't know. Anyways, it's kind of a little bit weird, but you know, you can start to see where the implications can definitely go with this.
Yeah.
So I'm gonna stop the recording here, and